Hello again, everyone. Today I wanted to do some research review. This is a paper that was published in the latest issue of Insect Systematics and Diversity, which is an Entomological Society of America journal. This was the Volume 8, Issue 4, July 2024 issue. And I did briefly, I think I tweeted this paper out, but now I have the paper in front of me and I wanted to go through it. This is a paper about the kind of trade-off that spiders have in their defense measures against predators, and whether they kind of rely more on their webbing or their bodies as a deterrent for predators. All right, it's called Disguise and Surprise Spider Anti-Predator Adaptations as a Function of the Architecture of Their Webs. And this is out of the University of British Columbia in Vancouver. It's a pretty interesting paper. It's not, it's not like the most elegant science, and it's not the most groundbreaking science, but it is really interesting, and it lines up well with our understanding of the relationship between kind of anti-predator defenses and microhabitats in animals. It's a fun paper, I would say. It's kind of one of those papers that I really enjoy this kind of science, which is kind of let's poke it and see what happens. Because that's kind of what they did. They went around poking spiders in the Ecuadorian Amazon rainforest and kind of see how they respond to predatory disruption. These were all diurnal spiders with different kinds of webbing architecture, and it was very, very interesting. So basically, and this, let me start off by qualifying this and saying I am not some sort of spider expert. Most of my life, I have avoided spiders because they are creepy. Although in the last several years, I've been getting more and more into them. And I've never really spent a lot of time thinking about spider web architecture. And this paper did a good job of explaining it and really kind of broadened my horizons when it comes to spiders. So basically, they went to Ecuador and poked around in the forest at different types of diurnal spiders. So these are spiders that are active during the day and would likely face predation from either other insects or other spiders, or birds or lizards or things like that. And if you didn't know, like, birds are a major problem for spiders, but as are predatory and parasitic wasps. They spend a lot of time hunting for spiders, and so spiders need some sort of defense mechanism. And the idea that I mean, it makes perfect sense, and I never really considered it, is what do spiders, how do spiders use their webs as a defense mechanism? And like I said, I don't spend a lot of time reading about spiders or working on spiders or anything like that, so I didn't know a lot about this, and it was a very enlightening paper. But there are basically 3 different kinds of spider web architecture. You have what is called a tangled web, a tangle and sheet web, rather. So in this kind of web, you have basically a bunch of, these are 3D webs, so there are both 3-dimensional and 2-dimensional kinds of webs. This tangle and sheet web is a 3-dimensional web in which you kind of have a random mess of tangles in a 3-dimensional space which funnel into some sort of sheet of silk architecture, and this forces prey and or predators into a kind of death trap zone. And then additionally, you have like the simpler tangle web, which is kind of a random assortment of 3-dimensional webbing that the spider can move freely around in, and that can entrap prey and or predators that way. Additionally, with all of these webs, they may have sort of either trash lines or debris lines and that act as maybe predatory defense, maybe defense against like flying birds to not hit things, or as a refuge for the spider to hide in, or to break up their outline so that they can't be so easily seen. And then you have the more traditional spider web, this is more like an orb weaver spider web, which is a 2-dimensional spider web where you have radiating web lines and then you have a circular pattern radiating outward. And again, these might have trash lines or something called a stabilimentum, which I have a picture of here, and orb weavers tend to do this, where they put varying designs of silk, usually in the center of their web, and this can be kind of zigzags around the web, it can be a spiral pattern, and what this is used for is kind of up for debate. When I was originally learning about these years and years ago, it was assumed that these were as a defense against birds, so birds could see this so they wouldn't fly through a web and destroy the spider's web. And it might be that, it might be used for mate detection. One of the theories that this paper talks about is that this might be an anti-predator defense, so that the spider can kind of camouflage themselves into this. And it, against like a silhouetted background, you can't see the spider silhouette as well on this stabilimentum as compared to if this wasn't there. So this paper basically went around and documented the kinds of spiders and their types of webs, the architecture of the webs. What kind of these three webs was it? Was it an orb weaver, like a two-dimensional web? Was it a tangled web or a tangle and sheet web? And whether or not the spider had some sort of refuge. Could it hide somewhere in the web from a predator, like on one of these stabilimentum? Or did they have like, sometimes spiders will drag like leaves into their webs and make like a tunnel that they can hide in, or maybe there's debris that they can hide amongst. And you've probably seen this, but frequently that is intentional. It's not just like the leftover bits of prey. Sometimes it's things that the spider brings in intentionally into the web as like part of the three-dimensional structure. So it was really, really interesting. So they did this documentation, and one of the things that they did was document not only the structure of the web, but the coloration and spikiness of the spiders, as for like, is it an aposematism where it's like warning coloration, warning spikiness, or are they camouflaged into their backgrounds, or are they kind of neutrally colored? And they tried to measure this as best they could. These are really kind of qualitative characteristics, but they did try to assign an arbitrary quantity to this. And this is what I say, it's not the most elegant of papers, but it is still really good, because when you're dealing with qualitative sort of characteristics in science, it's hard to do any sort of analysis with that information. So you sometimes have to arbitrarily assign these qualities a number. So how spiky is something on a scale of 1 to 5, or how colorful or aposematically colored is it, or is it camouflaged, things like that. And what they found is kind of what you would expect if you really sat down and thought about it, which is animals, or spiders in this case, which have three-dimensional webs that they can hide in, and especially ones with refuges, tend to be less spiky, they tend to be less aposematically colored, and they tend to have more defensive or neutral anti-predator actions. So one of the things that they wanted to find out is how these spiders would react to a predator attack. So they basically just poked the spiders and see what they did. Some of the spiders would attack back, some of them would try to drop off the web, some of them would do nothing, some of them would try to hide. But basically, if they had a refuge, or they were in one of these three-dimensional webs with this, this tangle or the sheeting, they would tend to be less defensive, or their defensive action would be to hide. Whereas like orb weavers that are very exposed, especially if they didn't have a refuge, would attack the researchers in order to drive off like the anti-predator attacking. And you do see this, like orb weavers without a refuge are much more offensive than something like a tangled web spider with a refuge, which are more either neutral or defensive. And it's similar to like the aposematism. If they're orb weavers are more, because they are more exposed, they're more likely to be brightly colored, showing that they are poisonous or venomous. They also tend to be spikier, so they're less palatable, whereas things spiders which can hide easier or have a three-dimensional structure on their web, they can rely on the protection of their webbing so that they don't need to evolve spike defenses or poison blood defenses or whatever sort of defenses they have as well as this sort of aggressive nature against predators. So there is this pattern of the more three-dimensional your webs, and the better you can hide in these webs, the less likely you are to display offensive behavior or defensive morphologies. So aposematism would be like a defensive morphology. Drive off predators so that they're not interested in you because you look poisonous or because you look spiky. And we talk a lot about morphology on this channel. So this is kind of a morphology in action sort of thing. Why insects or spiders evolve certain morphologies, which are associated with their microhabitat. It's not just the niche that they fill in nature or their evolutionary history as far as like what they're related to and the shared morphology amongst certain groups. It's also the microhabitat that they are evolved to live in will fundamentally alter not only their behavior, but their physicality. And we know this quite a bit and with other animals like birds and stuff like that, where they build their nest depends on how they live and their coloration and stuff. But it was really interesting to see this in arthropods. But one of the things that I really liked about this paper was something that they said towards the discussion, which is we have a hard time talking about these things. Was this in the discussion or was this in the results? It's hard to talk about these things because we are attempting to measure like the effects of coloration, the effects of spikiness, stuff like that, based on human perceptions. And we don't see the world the way that predatory insects see the world or predatory spiders see the world, both literally and figuratively. Like obviously we have our own personal interpretations, but we physically don't interact with the world the same way. We don't see the same colors. We don't smell the same things. We're not sensitive to the same spectrum of light. So a lot of arthropods can see ultraviolet, and many of them can't see like the color red. So like red colored spiders aren't, the red isn't there to defend against necessarily arthropods, but maybe it's defended against birds or mammals or lizards. So like the way that we interpret the data that is, the visual data that we're getting is not the same way that other animals will interpret that data. So this is just kind of a first go at kind of trying to quantify the effects of the webbing and the coloration and the spikiness on predation. But because we're not spider predators, we don't interpret it the same way. Because like spikiness, like we're interpreting spikiness as, oh, that looks really aggressive and unpalatable. But is that the same way that like why would a predatory wasp care about, or not even predatory, but why would a parasitoid wasp that is just trying to sting the spider to inject an egg and some venom, do they care about spikiness? Like, do other animals interpret the spikiness as unpalatable? Do they see it the same way we see it? It's hard to do that. It's hard to do that interpretation without anthropomorphizing the animals, which is a huge hurdle in research. And they bring special attention to that, which I really like, because it's not something that is brought up enough, really. So yeah, they brought it up in methods under this limitation section. It's a very interesting paper. It's not very long. I encourage you to read it. It is public access. It's open access through NSOC. I will link the page for this, so you can go to the journal yourself, go to their website, and you can see that if you want to read it for yourself. But it's super interesting, especially if spiders are not something that you think about a lot. Okay, I'll talk to you guys later. Bye.